Welcome, everyone. So, you are at Do NASA Science Live, specifically the event called Cosmic Pioneers Discovering Distant Galaxies Together. So, if you are looking forward to learning about dark energy, somewhat dark matter, in that we're talking mostly about dark energy, discovering galaxies, finding black holes, even, we are so excited that you will be here to help both teach yourself and teach others about all these wonderful things, and also to learn how you can impact real research. So without further ado, I'll go ahead and get us moving with what is happening today. If you do have any technical issues, I'm seeing a couple comments in the chat. Roland might be able to assist you. So if you send a message to Roland in the chat, he'll be able to help. And it might be that you need your volume turned up. Awesome. Okay, so Do NASA Science Live is organized by a whole awesome group of people. This is only four of the large group of individuals who help us. My name is Emma. I work for SciStarter as the Director of Programs and Operations. And so if you have questions about SciStarter altogether, myself and also Roland can help you answer those questions. So also along with us today is Roland, who I mentioned for SciStarter, and then also Sarah Marcotte, who's joining us from the NASA side of things for the NASA Solar System Ambassadors. And then Darlene is the founder of SciStarter. I'll give them a chance to say hello and properly introduce themselves later on as well, but I want to keep us moving so we can get started with the project too. All right, so before we jump in, I want to make sure everyone's on the same page. We are talking a lot about something called citizen science today. This is also related to community science and participatory research, crowdsourced science, all of the above. A lot of it is synonyms for something in which we are helping real research move forward. It's a collaboration. So we're working across the globe to accelerate research using the power of the crowd, where we collaborate with scientists to make that happen. And you can do that from anytime and anywhere. You'll notice that a bunch of you in the chat are from various different countries, and we're so happy to have you here at these various time zones, probably. And so the actual project we're working on today, you may have questions. So if you have questions about the actual project, about the science itself, feel free to drop things in both the chat and the Q&A. The Q&A is if you want it heard aloud and spoken to the whole group. The chat is also for folks who are answering, because we have a bunch of experts in the crowd who are either volunteers on the project already, or people who are really good at physics and love astrophysics and can answer some difficult questions for you. So feel free to make notes in the chat, and then you can also definitely add them to the Q&A if you want them out loud, and we'll make sure to cover them as quickly as we can. So the project we're actually talking about today is Dark Energy Explorers, and we're joined by Lindsay House, who earned her PhD in astrophysics from the University of Texas at Austin, where she focused on dark energy cosmology. So I'm going to let her give a nice nutshell representation of herself and what this project is before we actually get you all set up. So I'm going to pause there. Lindsay, go to you.
Nice. Awesome. Thanks, Emma. I'm super excited to be here. And thank you guys so much for having me doing Dark Energy Explorers, and for everyone who's here. So if you don't already know me, I'm Lindsay. I'm the project lead for Dark Energy Explorers. And yeah, I just finished my PhD in May, which was super exciting. And I started this project 5 years ago, literally to this month in February. And so now to have this community of people who want to spend their free time classifying galaxies is such a dream come true. So thank you guys so much for coming to spend your free time with me. If you have never done Dark Energy Explorers, I am so glad you're here. You're right where you belong. We will teach you everything you need to know to classify these galaxy spectra. But before I tell you a little bit about the project and why I got it started, I would love, if you haven't already, for you guys to post in the chat of where you're tuning in from. That's one of my favorite parts of these events, because we truly have so many people from so many different time zones and places and countries all over. So please, if you haven't already, I'd love to see where you're tuning in from. So why did I start Dark Energy Explorers? Well, I grew up in North Carolina, and my high school didn't even have a physics class, let alone a astronomy class. And so it wasn't until later that I wanted to pursue astronomy. And so I created Dark Energy Explorers because I wanted to give people who might not have had access to astronomy the ability to participate in real live research. And what's better than mapping the universe, right? So I'm pretty excited that we're going to get to do that today. So, as a part of Dark Energy Explorers, we're classifying galaxies from 9 to 11 billion years ago, creating one of the largest maps of the universe ever produced on one of the largest telescopes in the world. And so, by creating this map, it's going to help us to understand how fast the universe is expanding at different times within the universe's history, which will help us then understand how fast it's accelerating. And that's what we call dark energy and how dark energy is playing this role in our universe. So stay tuned.
Amazing. And for anyone who's thinking, I really don't know what dark energy is, I'm along with you. I forget every time I'm taught it. So we're going to learn the right way and in finality of how to remember what all this means too today. So if you're looking forward to that, be aware we will come back to that idea. So thank you so much, Lindsay. That is awesome. Before we start the project, I'm going to have us do a one-time setup to be able to make the most out of today. In order to do this, though, I did want to shout out a couple of the folks who are out there in the various locations across the country. If you are participating in a watch party or satellite event, we'd love to know where you are, especially calling in from, because you might have a group of folks you're representing. So feel free to say so in the chat to let us know. And also let us know what you're so excited about to be participating in today. And I'll keep an eye out for that in the chat as well. So, for all of you who are new to citizen science or projects in which you are doing any form of research or STEM related activities, we're going to break down how to use a certain program, one of which being SciStarter, which is the largest database of citizen science projects. So, you'll have access to the whole world of citizen science, or as much of the world as we can gather at this moment in time. And then we'll also teach you about a specific platform. So, Dark Energy Explorers is hosted on a citizen science platform called Zooniverse, which is a partner platform of SciStarter. So to get us all set up, we're going to go through a quick, hopefully, process. That said, if you need me to slow down or need to repeat any instructions, I will do so, as well as I will actually demonstrate it for you as well. All right. I'm loving the amount of places we're seeing in the chat, by the way. This is incredible to see so many folks staying up in the middle of the night for this. So thank you to all the 2 a.m. folks. We see you. All right. So first of all, SciStarter being the largest database, if you have a SciStarter account, that means that you have access to that giant database and all the other wonderful things that comes with it. So the first thing we'll ask you to do is create that SciStarter account. Now, our friend Roland will be adding these steps in the chat for you, so you can find those links. I'll also be showing you from my screen, but I'll give you all the steps first in case any of you want to jump ahead. So step one, we'll have a SciStarter account. Great. Once we've done that, we're also going to create a Zooniverse account, which is the partner platform I'm referring to. So in order to actually participate in the project you're doing, that'll be through Zooniverse. All right. All right, so you'll be sending yourself over to Zooniverse. Zooniverse.org is the link you'll see in the chat momentarily. And then you'll do the same credentials. It really doesn't matter too much. The key thing here, though, is you're going to remember that username that you use on Zooniverse. That Zooniverse username is the key to all. Okay? All right. Now, once you've done that, and I know I'm going fast, I'll do a demonstration of this after as well. Once you've done that, you are also going to go back to SciStarter and you're going to add that Zooniverse key, that username. You're going to add that to your SciStarter account under Info and Settings. We have this special thing called Affiliation Integration, in which if you add your username there, that allows you to track your progress over time, and we'll be able to actually see that in real time tonight. And so if you want to see how much you're doing over time, and you want to see like how much you do of other projects too on Zooniverse, that is all going to be housed on SciStarter. So you'll be able to see your progress across different projects. There was a question that I saw about logging into SciStarter first. If you're not logged in and try to go to your dashboard, it'll say you're not there yet. So make sure you're logged in order to get to that dashboard. That last step that we'll do after that process is to just go to the project and we'll get started. And I'll show you what that looks like on both SciStarter and on Dark Energy Explorers. And so that is it. Oh, question. Do we have to add the at in SciStarter or just our username? Just the username. You don't have to use the at. Yeah. Great. Y'all are doing amazing. I know I went through that fast. I'm going to demonstrate it for you and then we'll get moving and we'll make the most of our time. I think this is probably, hopefully, I'm going to jinx myself right now, but this is a pretty fast version of getting through it. So y'all are doing wonderfully, I'm assuming. Okay, great. I'm going to go ahead and pause my share so I can shift it over to our first step. So our first step here, resume. Our first step here was to go to scistarter.org/login, which is up on the top of my screen here. I'll go ahead and zoom into my screen too because I have a big screen to work with. And then I'm going to either log in if you have an account already or create a SciStarter account. I'll go ahead and create a new one just for fun. And I'll do a sneaky trick um, with my account so that I can have multiple accounts with the same email. I'm going to skip username just because I want to be fast. And then I'm going to make up a password. And hopefully do the same thing twice. There we go. There we go. And then you can sign up for the newsletter. You're welcome to. Many of you, when you registered, already said you want the newsletter. So you'll have the newsletter after this as well. So you're welcome to either keep it or not. And then terms of use is required. So you'll keep that as well. Just watch my password not match. We'll find out. Oh no, it worked. Okay, good. Awesome. Okay, so now that I'm here, this is my lovely dashboard. I do up here have my name, which is 320548, which is a great name, but we don't really need to worry too much about that. I'll create a better username at a later time, and you are welcome to as well. So now that my account for SciStar is done, I'm going to jump over to Zooniverse. So I snuck over to the project page already, but this is not what you would see. So I'm going to just go to zooniverse.org, which will take me here. And they don't have a login like URL. Instead, you're going to go right over to the top right where it says sign in or register. And you'll do that. And you'll go to register to create a new account or go to sign in if you have already have an account. I see some questions in the chat, so I'm going to pause for a moment. Have you added your Zooniverse? Oh, okay. So if we're missing steps, yeah. So I'll keep moving so that you have the right. You have a Zooniverse account. Do I need to do the SciStarter account process? In order to participate today, you do not have to. So if it won't like prevent you from participating, but it is something that will help in the long run, especially when we're working towards April, which I'll talk about later in today. But if you are looking to do more of this and more than just this project later in April, especially for Citizen Science Month, it'll really make a difference, and I'll explain why. You can also do it at that point in time if you'd like to move on right now. All right, so I'm going to go ahead and add a username. Let's say my name is Emma, because it is, and then today is 2/11, which will hopefully not be taken. And then I'm going to use the same email that I used before, because that is just easy to do, at gmail.com. Let's see if I'm allowed to copy paste. That'll be nice. Yeah, okay, great. Which is not always advised just in case that you make a mistake, but helpful for me right now. All right. And then again, similar to us, our privacy policy on SciStarter, similarly here, I'm going to go ahead and hit yes, I agree. They do have email newsletters as well. So if you'd like to be updated upon all these things, you can do that as well. All right. I'm checking in the chat to see if we have any um, other questions. Desmond is telling me that he likes my username. Love it. I do too. All right, so now I have an account. That's great. So that third step in which I am going to revisit SciStarter to add the Zooniverse username is what I'll do next. So I'm going to say, okay, I'm here. My username is Emma211. So I'll copy, go to my dashboard, and info and settings is on the left-hand side here. I don't really want to do that right now, so I'll do never. And then if I scroll down, it asks me a ton of questions. I don't have to answer any of them, but I do have to go down to here. Your Zooniverse username, capitalization does matter, forewarning, and I'll go ahead and add that there. In the top right-hand corner, you'll see unsaved changes. That'll change when it's ready, and then I'll be good to go. And that's it. Done, done, done. Now, I do this all the time, so it takes me very little time other than the whole narration. So hopefully it's easy for you all, but if you do have questions, we're watching to see if we have any questions. Oh, can we record or take pictures of the meeting and share them? Yeah, totally. Feel free. I'm assuming you mean screenshots. Oh, this does not want to save. Hopefully my Wi-Fi is not being weird. If I hold on to the page, or at least I don't get rid of it, it'll probably do it while we wait. Okay, so yeah, you're welcome to take screenshots of this event. I think that'd be great. You can also share the live stream from your from our Facebook page to yours, by the way. Thank you for mentioning that, Roland. Yeah, we're sharing to a bunch of different SciStarter pages, so feel free to join us. If you go to facebook.com/SciStarter or click in that link in the chat, you can go and hit share and it will go to whatever thing you direct it to. If you post on socials, oh yeah, nice. Yeah, and I had a slide with your credentials on there too, so I can jump back to that at the end if anyone wants to follow Dr. Lindsay House. Honestly, Dr. House, what a fun name.
I had to get a PhD, you know.
Yeah, kind of had to. Awesome. Oh, and you're streaming to Twitch. Thank you, Desmond. Sweet. I hope we have lots of people in there. I feel like this is a very gamer-friendly activity, so I love it. All right.
Emma, I
Yeah.
have a question in Q&A that other
Okay.
people might have. Um, Ava has been a member of Zooniverse since fall 2023, and she does not see her projects she's completed over in SciStarter, but she just set up her SciStarter
Yeah.
account last night. Would
Oh,
SciStarter track her stuff from now going forward? It won't pick up previous
yes, I believe
activities.
so. Roland, do you
Okay.
want to confirm for me? I'm pretty sure that is how it works, but
Yeah, I
so
should think it's just kind of moving forward. If you just
yeah.
started your SciStarter account, it won't get previous
Yeah, the
activity.
retroactive data will not appear,
Okay.
unfortunately. I know. I wish it did. Maybe we'll figure that out at some point, but I'm personally not the computer engineer, so unfortunately I don't know how to
Well,
make that
it's just a
happen.
reason to go in and go do new projects in Zooniverse.
Yeah,
Get them
exactly. So,
tracked over there in SciStarter.
oh yeah. How do we find the project? Perfect question, because we're about to do that. Yeah. Oh, great. You did a Galaxy Zoo. That's great. Yeah, if any of you have other projects you do on Zooniverse already, those will count too if they're SciStarter affiliates. So that is the one thing. Like we have partnerships across a bunch of projects, and so not all of them necessarily will be tracking, but a good chunk of them. So hopefully we can cover the ones that you're a part of, and if we're not, then tell us which one it is, and we'll go and hunt down the project leader to say, hey, people want it tracked. And then that gives them better reason to participate in that. All right, so we're going to go ahead and find that project now. So for anyone who's looking at a set of steps on a piece of paper, for example, it's a little tough to go and like find that project from clicking on a link in the chat. So I'm going to show you how to get to that. So I'll go ahead and click on Zooniverse as my tab again. I'm now on my account. I'm going to go to the top left where it says projects, which I know is tiny on my screen, so hopefully you can see this on your screen as well. If you are on a phone, by the way, there is a mobile app for Zooniverse that works the same way, and you can find Dark Energy Explorers on that app as well. I did check. So you can do that as well if you're having any trouble there. So there's a ton of projects on here. Many of them are well loved on the SciStarter platform as an affiliate, so hopefully you can do a bunch. And then I'm going to go ahead and search Dark Energy and wait. Oh, I bet it is my internet. Sorry, y'all. Hopefully it'll be quick. There we go. Awesome. And then you can click on that Dark Energy Explorers as the project, and you've made it. So we are going to pause here for a moment to make sure everyone is covered. I do have a couple of things I want to talk about before we jump in. If you're thinking like, oh yeah, I got this, I want to get moving, feel free. What you're going to do though is if you go to Classify to get started, there's a thing called a tutorial that we really want you to take before doing anything because that helps us understand that you know what you're doing. It helps you actually know the process of how to classify the different galaxies or classify whether or not it is a galaxy. So just be aware, take the tutorial before you just jump in. However, before we do that, I did want to take a moment to just explain that Zooniverse is a large platform. It's got a bunch of different projects that you can choose from. We're doing this one specifically today together, so hopefully you'll stick with us for that. The tutorial is right over here, by the way, once it loads. There it is. Ta-da! And so you can use Zooniverse to do a lot of different projects. Within Zooniverse, it'll always give you a tutorial because they want to teach you how to do the actual process. This is real science, right? Citizen science is serious science. And so as a part of this, you'll be taught the specific protocol or steps in order to get to the right answers and then help get through all this data. There are also pieces called the field guide. There's a info section where you can go to the about and learn more about the project. There's a lot of features on here that you should absolutely explore, and we'll probably spend some time jumping from various spots. And so if there's something you want to look into or have questions, we may end up going there at some point. So think through your questions about this, even if it's like about Zooniverse 2, we want to make sure that you're covered and understand how to use all this. So before we go deeper into this training, which Lindsay's actually going to lead me through to avoid it being just us reading, I did want to ask, so these are pretty unique images. These are pretty like they don't seem like images at first, right? Because they're different. They're not just a photograph. So what are we actually looking at, Lindsay, when we're looking at these scans, I guess?
Yeah. Yeah. So we're looking at galaxies. These are images of spectra from galaxies and occasionally a black hole or two. Maybe we'll be lucky enough to see one in our data tonight. But these are the galaxies that we use to create this map of the universe. And they're the spectra. So what is a spectra? The spectra is this pattern that forms when light separates into its component wavelengths. So what happens is the light is traveling from these galaxies, so traveling from 11 billion light years away. The light hits our telescope mirror, and what we're looking at is these dots that we're going to see, and those dots are the photons or the light from the galaxies that we're collecting. So it might not look like what you typically think of like a big spiral galaxy with colors, but it's the actual light traveling from the galaxies that hits our telescope. And then we see that as these dots in the spectra.
Amazing. Very, very, very far away.
Very far away. Yeah.
And where are these coming from? I assume it's because HETDEX doesn't refer to the actual location, right? That's the project it's associated with.
Yeah, exactly. So HETDEX stands for the Hobby Eberly Telescope Dark Energy Experiment. And the Hobby Eberly Telescope is located at McDonald Observatory, which is out in West Texas. It's about an hour outside of Big Bend National Park. If you're ever out that way, definitely recommend going to McDonald and going to a star party, seeing the Milky Way. It's super gorgeous out there. It's one of the largest international dark sky reserves. So it's super, super dark out there. Some of the best views of the Milky Way that I've ever seen. But so it's located out there. It's super dark. So we get great images of the sky. It has a primary mirror that is 10 meters across. So that makes the Hobby Eberly telescope the third largest telescope on the entire planet. So it's super
Wow.
cool. You guys are seeing all the data from one of the largest telescopes in the world.
Wow, that is very cool. I've never been to that telescope, but it looks like some of our people who are making comments in the chat have been there. Desmond, have you been there, or you just think it's beautiful? And then Rebecca let us know. Went to Okie Tex this past September. Very cool. Is that in that area? I don't know where that is. My limited knowledge. Awesome. Oh, cool. Okay. And there's also a group of folks called, or is it the Volunteers for Dark Energy Explorers? Middle school? Okay, yeah. Wow. Ooh, great question. So a couple more questions. I had a question about this first. So why do we need to look at these scans? Like, what are they actually going to tell us?
Yeah, so what we're trying to do here is the really unique part about HETDEX is that it is an unbiased survey. So normal telescope surveys are pointing at specific objects. So you point at a certain galaxy or a planet and you observe it, right? But HETDEX is an unbiased survey. So we're just pointing the telescope up at the sky and collecting as much data as possible. And then it's our job as the research team to sort through all of these galaxies and everything. So we want to make sure we have this really clean sample of galaxies, and we want to get all the junk and all of the things that aren't supposed to be in our data set out so that we can actually perform our science.
Sweet. And that probably means we have too much data potentially. So I'm excited to see that. There was a question about the amount of data there. I'm going to go ahead and move us through this tutorial first, but we'll come back to that. Mia, who asked about the 97% complete, which is good to understand about Zooniverse as well. So we'll come back to that. Just bear with us for a moment. So I'm going to run through this slowly, or at least I'm going to switch screens as you want, Lindsay. So do you want to just tell us a little bit about what this tutorial is telling us so we don't read it word for word?
Yeah, absolutely. So yeah, if you want more detail, you absolutely, it will always be here. But so first thing, we are going to be looking at some of these spectra and the spectral line here. We collect this spectra of these galaxies, and basically, we don't have any numbers or any graphs. We don't want any sort of jargon here. We're just looking for a really nice line of best fit. So we want to make sure that those blue dots are pretty lined with the black line of best fit. And so sometimes we might have error bars that are a little bit bigger or smaller. But as long as it's an overall emission line, so a big bump coming up, that means that that spectra is good.
Okay.
Yeah.
Cool. Good as in it's likely to give us data
It's
on a
Yeah, it's likely to be a real galaxy that we want to keep. Yeah,
instead of those fake galaxies that just try to
exactly.
show up.
Exactly. I gotta get those out of here.
Okay. And then here we're looking at the other images. So I'm going to scroll down to just this so it's the visual, but what do we
Great.
need to know about the other signals? Or
Yeah. So I like to think about first, we'll look at the colored boxes on the left. So there's blue, green, orange, and red. And all of those stacks on top of each other is the black box at the very top. And so I like to look at that one first. And then we have the spectral line down at the bottom that we looked at. So we're looking for that best fit down at the bottom left. And then we have the actual image on the right side, a zoomed in and a zoomed out version. And then at the bottom right, we have a flux map. So these five things are what I like to look at first. And I like to think that if there's something in about three of these five, then it's probably a real galaxy that we want to keep. And if not, then we want to throw back, we want to get it out of our data. Um, and so the colored boxes are these fiber images that come from our telescope, which has a bunch of different fibers. And you can see each of those colors is actually in the actual image on the right. If you see the circles at the very zoomed in top, yeah, the blue, orange, red, and green, those each correspond to the fibers on the telescope on the left side as well. And so what we're looking for in here is a dark black dot. So those are the photons that we're actually capturing from the galaxy's light that have traveled to us to the telescope.
excellent. And we did have two questions come up that I think are excellent ones to stop at. Sarah, I don't know if you caught this one or if this is in the Q&A too. Let me jump over to it just in case. There we go.
Is that Eric's question?
Yes, Eric's
That was a
question.
good one.
Yeah. Eric is asking, I'm curious how many times each image is classified before confirming it's a galaxy.
Yeah, that is a great question, Eric. And that is what I did almost my entire PhD on. And so one of the things that we did a lot of statistics and a lot of testing to be sure. But yeah, we have a minimum of 10 people looking at each of these images and classifying that it's a galaxy. And then we use that in addition to a lot of information we have on the back end to then form our catalogs of these real galaxies. But yeah, that's a great question.
And there was also a question about asteroids, but it was about whether or not some of these my joking comment about fake galaxies, could some of those blobs that are not so great of data also be meteors or asteroids in line of sight?
That is, yeah, absolutely. They can. And so, yeah, anything that obstructs our view of the telescope that is considered junk to us. So meteors, asteroids, satellites, which are getting more and more popular in the sky. We want to protect our dark skies. Satellites are actually a huge problem in our data because they pass right in front of our telescope and they look a lot like a really bright star that's going to streak across all of our data and mess things up. So we do a lot on the back end for getting rid of satellites. But yeah, the Hobby Telescope is an open air telescope. So, the dome opens and it's massive. It's a feat of engineering. But anything from like a moth or a bird flying in and hitting the telescope mirror is going to be something that we have to get out of our data set, and that's just the reality of like real science.
Yeah, I remember looking at this project the first time and thinking that it was a satellite telescope in space, and I heard the comment about moths hitting it. I'm like, that's hilarious. Moths
Yeah.
can't be in space. And now I'm like, okay, wait, no, never mind. That makes more sense now. Amazing. Okay, I'm gonna go ahead and back out of this to go to the next one. And then or maybe I'm not. There we go.
Yeah, so this one is just a special note on black holes so that you guys can keep an eye out. If you happen to see something like this, it means you've probably found a black hole, which is really exciting. So black holes appear like this large, wide oval rather than a small, more circular dot. And so the black holes will also have a really broad spectral line because remember we talked about the light that's traveling from really far away. If you think about how light is distributed in a black hole, it's being stretched apart, right? So that light is actually capturing that really broad spectral line that we get from the black hole, and that's actually that light that's being stretched in the black hole.
Wow. And this is telling us the difference between black hole versus galaxy, but that was a great question I just saw in the chat about confirming whether it's galaxies or stars or other stuff. Is it just, are stars and stuff can we find them through different imaging, or would this be the same type of imaging that we would use?
Yeah, no, we can absolutely find stars. Stars, if you've been with Dark Energy Explorers for many years, we had a different workflow way back when that had included stars, but we've actually got most of the stars out of our data sets now. But yeah, stars, absolutely, we can. One of the big indicators between stars or different types of galaxies or the black holes are those different wavelengths. And so these are spectra, and this one actually has some numbers on it. That is one of the biggest indicator. We can go in our data on the back end and we can actually see what wavelengths these spectra are sitting at. And those are like fingerprints to different types of stars, different types of galaxies. And so that's the big identifier for us whenever we're looking for which one is which.
Ooh, cool. So we don't
Emma,
really have to worry about running into them.
Wait, sorry, what did you say?
We don't necessarily have to worry about running into stars to and
We
mislabeling things.
probably won't run into any stars today,
Okay,
yeah.
sweet.
But
And sorry, Sarah, are there questions we should?
oh, I was just saying, I do have, I just saw two similar questions that I thought might be useful to ask when you're ready.
Go for it.
Oh, okay. Both questions have to do with AI and machine learning. Like,
Oh,
why are AI and machine learning tools not doing this, or are they doing this? Why are humans doing this
wow,
project?
great question.
I'm paraphrasing here.
Yeah,
But
no, these are great questions, and I'm glad you guys are thinking about this. It kind of seems like you guys are dying to read my PhD dissertation, because that is exactly what I did for my PhD. And so, my research is really on this combination of using human labeled data with machine learning and combining those two so that we make sure that we have humans in the loop, but we can also do it really a lot more fast and a lot more efficient whenever we include machine learning. And a lot of the research that I do is cross-checking and, like Eric mentioned, making sure that we have this reliability and accuracy with the human labels and the machine learning. And we've really found the combination of both of them together is what really outperforms. So not necessarily just the machine alone or just the humans alone, but this kind of combination of both of them together is what I did my research on. So happy to send some literature your way if you guys are interested in reading.
we
well,
just got a bunch
people,
of requests
yes,
for your
people,
dissertation.
people
Great.
actually want your dissertation. It's gonna
All
Oh, man.
right,
sit on
great.
their coffee table and they can read it.
We will make sure to add it in the follow-up email, I think, if that's
Great.
possible. Yeah, we definitely will. All right, what are we going to throw back? What's the bad data we're going to remove from the situation?
Yeah, so it can come in all different shapes and sizes, but you can see here as it circles through this GIF, sometimes we have bad calibrations or bad data. Sometimes it's a huge feat of engineering. This thing is massive, so one thing goes wrong with one fiber, and we get something that looks a little wonky from our data or on our telescope. The meteors and the satellites are going to look like these big streaks. So you probably will be able to differentiate them from the black holes because they will be more oval. The meteors, yeah, something like this. This is either something that's wrong with the telescope. Oh, it already went away. But or it's probably a meteor or a satellite that's gotten in front of our data. But yeah, or in front of our telescope.
Okay,
So a
that's
line
great.
as opposed to kind of an oval, like a black hole,
Yes,
like it's
exactly.
just like a straight pixel line.
Yeah, so that's probably a pixels defect, that straight
Mhm.
line that we had there, but I think here it comes back around. Um,
And on that note, while you're waiting for it,
yeah.
what is a fiber? That's a great question, Mary Jones Parker. What is a fiber?
Yeah, so oh, it went away, but all right. So yeah, so the fibers are kind of just a part of the instrument on the telescope. So I said that the telescope mirror was 10 meters. It's actually really cool. I feel like we could give a whole talk about the like engineering of this telescope, but the 10-meter mirror is actually made of 91 hexagonal small mirrors that are all put together like a tile floor. And each of those hexagons has all of these fibers that are connected to it. And so you can imagine light traveling from, light years away. You have to have an insanely sensitive device. Yeah, you can almost think about it like fibers, like receptors in your eye and how your eye absorbs light and exactly like that. And so whenever you have all of these fibers on the back end, on the other side of that telescope mirror, on all of those different parts of the mirror, we're collecting that light, and it's incredibly sensitive. So we have all of these fibers on the back end that actually capture that light.
Excellent.
Yeah, yeah,
Great.
that was a great analogy.
All right, let's close out this. Is there anything else we should learn from the tutorial before we jump in?
I think that that's about it. Yeah, but I'm happy to keep
Sweet.
asking questions if it comes
Yeah,
up.
there are so many good questions in the chat.
Yeah, there are a lot of great questions in the Q&A as well, but let's get to doing some images ourselves, and then if we have a little time at the end, there's
Yeah,
some.
sounds like a plan. All right, so this is our first one. This is real data. Someone had asked earlier if this is real data we're working with. Yes, yes, it is. And you got this. You don't need to be afraid of making mistakes. That's part of the research that Lindsay did. All right, so just off the top of your heads, for anyone who's looking at the same image as me, does anyone have a very distinct, specific answer for what they think this is? If this is something we should keep or throw back? Oh, Rob already said throw back. Who agrees? Oh my gosh. All right, y'all do not like this one. How do we feel about this one, Lindsay? Do you agree with them?
Yeah, this one's a tricky one to start off with. I would probably agree. I would probably say throwback. So at the top, you can kind of maybe see a little bit in the black imaging, but nothing really on the right. And the spectral line, yeah, is not super great. That one dot up there, but yeah, it's not super great. This is a tricky one, but I would probably say throwback.
Awesome. Y'all are so good already. Sweet. Just know also for Zooniverse, if you are unsure of yourself and just want to kind of validate why you're unsure, you can always hit done and talk and say, I have no idea, or like something is weird about this one. What is it? And you can actually continue the conversation. So feel free to do that as you're going through if you need. Daniel's asking, why do you say it is a tricky one? Is there something in particular that makes you feel like it should be a yes at first?
Yeah, so it would be a really like a stronger dark black dot that's a little bit bigger and more prominent. Yeah, there in the black top on the left, and
Mhm.
also in the images on the right. You can see it's very, very faint. Yeah, right there in the middle. But exactly, it's not super, super strong.
Yeah, this one trips me up, where it's like it looks like it could be substantial, but maybe it's the rest of it's not convincing. All right, moving on. All right, anyone from the chat letting us know what is your initial thought about this one? Man, y'all are so good.
Oh, yeah, you guys are professionals already. We've only done two examples.
Not even.
Yeah, exactly.
Amazing. It's from your excellent articulation of what we should be doing or looking for. All right, why do we want to keep it? Looks like a lot of people saying keep it, and then a
I
hello.
know that's so unusual for the scientific community, right? No one ever agrees on everything.
Hello. What looks good? I mean, for me, it looks good. Like looking at this graph, I usually end up looking at the, oh my gosh, what is it called? It's called spectrogram.
Spectral line. Yeah, emission line.
Spectral line. It looks convincing to me just seeing it actually go up into a peak. And then I can see a dot. I can see a dot here. But because there's also like light in the middle of that dot, I'm tricking myself a little bit too. Does it matter if there's like a little bit of light?
Yeah, no, as long as you're seeing overall like that black box at the very top is that composite of all of them together. As long as you're
Mhm.
like overall your eyes are making some sort of pattern that it's a dot, then I would say that you're seeing it.
Oh, sweet. Awesome. All right, I'm gonna follow all of y'all's advice and say keep this galaxy and go to the next one. There was a question because, and someone brought up another similar question about data. If any of you noticed, if I go to the about page, or no, not the about page, if I go back to the main page, you're at 97% complete. And if you scroll down, you can see how many subjects are left. I was curious, you just have so many subject, right? So even if you're at 97%, that still could mean 10,000 more images, or how does that work?
Yeah, I don't think I mentioned this at the beginning, but take a map, to make a map of the universe, it truly takes so much data. It's hard for our brains to even wrap our mind around how much data we're collecting. So never fear. We have so much data for you guys. If it ever says that, or if you ever see that we're out of data, you can send me a message, and I can try to get some more data up. But basically, yeah, we can only upload a certain amount at a time, or else we would crash Zooniverse's website. So we just upload sets of data at a time. Actually, if you go back down to the statistics,
Mhm.
and this might be helpful for you guys, if you hit view more stats there. Yeah, so the current workflow that we have, fishing for galaxies in a sea of noise, you can see that it's like 40% complete, and the estimated time to completion is like 892 days. So I think we'll be okay.
You all can speed that up though. Start
Yeah,
working on that. That'll
exactly.
get it shorter. Even not just by
Exactly.
the days. Like in 2 days, we'll have gotten rid of 4 days potentially on this.
Exactly.
Okay, I'm gonna go back to classify. Do we want to pause for a moment for any of the other questions, Sarah? Anything relevant to what we were looking at?
Let's see. Well, Eddie is wondering, and I might wonder this as well. What does the spectral line tell us about the galaxy, and how is it related to dark energy?
Yeah, great question. We haven't even talked about dark
Yeah.
energy that much. So the spectral line, that is we think of spectra as almost the fingerprints of these galaxies. And so each of them is unique, and we can see those different wavelengths of light from the galaxies that we're capturing from our telescope. And so, yeah, how does this relate to dark energy? So dark energy gets its name because it gets its first name, dark, because it can't be visibly detected, or at least it hasn't been yet. And you might say, Lindsay, well, how do we research or how do we observe something that we can't see with our own eyes? Well, we actually do this a lot. with gravity, we can't see gravity, right? But if I drop something, it's going to fall to the ground, and we can observe gravity in that way by observing how other objects act. And so that's exactly what we're doing to understand dark energy, is that we're mapping these galaxies, and we're going to track how these galaxies move, because dark energy is expanding our universe. So we'll track these galaxies as they're moving through the universe's history and time. And so how we see these galaxies move is actually will tell us a lot about our different theories of dark energy and its effects on the universe. That was a great question.
Wow.
Yeah. And I'm wondering now if there's a moment, do you want to show off your jar to describe dark energy too? If
Sure.
someone needs a visual, I'm gonna
It's time
take.
for the jar.
I
Yeah.
love this so much.
Yeah. So one of my favorite demos, because I think it's just so hard we're so used to thinking about regular matter. So regular matter is you and me, your cat, your dog, everything here that we can see is regular matter, right? Oh, great. Other people have already seen my jar.
Sneak
Spoiler
peek.
alert. So I have this jar of beans and beads. And what if I told you that I could explain the whole universe with a jar of beans? So if we think about this jar as our entire universe, dark energy makes up about 70% of our universe. So all of these black beans are dark energy, and the brown would be dark matter, which is about 25% of our universe. But regular matter, like me and you, is about 5% of our universe. So I have these little colored beads here that you'll see them every now and then. And so those are the things that we can actually see and observe, stars and galaxies with our own eyes. But everything else is dark energy or dark matter. And so truly, there's so much that we don't know about the universe and that we have to discover with the galaxies that you guys are classifying. So
It's
And now people are
daunting.
asking about the beans.
About the beans.
We're supposed to be
Different
talking
types of
about black
beans.
holes, and they want to know
black
about those
beans.
black beans.
Black
Exactly.
beans, pinto beans, and beads too.
And some beads, looks like some pony
Beads.
beads. Yep.
Yeah, it's a great demonstration. I think I won't make you do it, but too in that video, if you haven't seen it, which you know what, Roland, if you go to the Cosmic Pioneers event toolkit, it's in the supplemental resources. It's a YouTube video. If you find that, feel free to drop it in the chat for us, because it also includes a different demonstration with a balloon that might help too for understanding the universe. But yeah, it's crazy. And I want to pause to see, Sarah, if you've evaluated any other questions that should come up now before we start, or if before I show more examples of the project.
Let's see. Two kind of technical ones. Some of the people in this audience, I can tell, are technical and are budding astrophysicists. So one is from Tori, wondering which wavelengths of the EM spectrum these represent.
Yeah.
So which
Mhm.
wavelengths? And then a second question is, can one derive red or blue shifts from the spectra? So that
Mm.
would, I guess, mean the galaxies moving away.
Do you do Redshift Wrangler by chance? When you asked that
Right.
It sounds
question.
like.
So we'll start with first the wavelengths of the
Yeah.
EM
Yeah, so
spectra.
the specific galaxies that we're interested in, that they sit at that about 11 billion light year range, those are called Lyman alpha emitting galaxies. And so that's the specific, that's how we can tell what they are with that specific wavelength. And so that's an emission line of hydrogen. And so that's what we're actually detecting in the wavelengths of our telescope. Great question. I love that you guys want to get into the details. You're gonna love what I have to send you. Have more reading to come.
Right. And then the red and blue shift. So can you tell? And that would be them moving through space, expanding or.
Yeah, exactly. So all of these galaxies, um, since we're talking about dark energy, they're pretty much all going to be redshifted because they're moving away from there and they're so far away from us. And because dark energy is expanding the universe and it's expanding the universe at accelerated rate, so it's getting faster and faster. And so, yeah, we will see those galaxies that are being redshifted or moving away from us.
Okay, I think we could move on.
Yeah, and I'm trying to, sorry, the link I put in the chat is probably not the right one for the YouTube video. I'm trying to send the right one, but this might be it. It's just feeding it through a longer link than I expected. All right, yeah, I'll go ahead and share screen so we can do a couple more examples before we close out. All right. Y'all are so good at this too. Should I just ask the question again of who votes keep, who votes throwback? Oh, and Jeanette's already there, so I can throw back. All right. Anyone else agree? This is making me nervous because it looks like I can't see part of the data. So if there's something going on there, that might be a problem. But then I have this lovely dot visible.
Yeah, and look at that peak in the lower
Yeah.
spectral line. There's a few things lining up with that peak. Not
Yeah.
everything, though.
Although, should I be scared of this section with the
Yeah, yeah,
outliers?
right. There's quite a few outliers. You're right.
Ooh, we're split on this one. It looks like some people are saying keep, some are saying throwback.
But in that top box, I'm kind of liking the smudge right in the middle.
The smudge. Yeah.
Exactly.
The schmutz.
Yeah, no, all of these things that you guys are talking about are exactly correct. This is another tricky case. This is one that honestly us like in the internal team might even fight over because you're exactly right, Emma, that one at the bottom right. So it's an edge case. And so what that means
Oh,
is that it's falling on one of the edges of our telescope mirror. And so it's hanging off a little bit, but I agree that you're seeing a really great dot at the top in the black box, and the spectral line looks like okay, not great. We're not seeing a ton in the zoomed in and out images, but we are getting something too, even though it's halfway off. So this one could really go either way. We would probably see this that people have said throwback or keep, and it would probably be right in the middle whenever I like evaluate things. And then we would go in and look at a lot more data that we have on the back end just to see kind of make an actual decision. But if I was doing it, I would probably say keep. So.
All right.
ah, because there was actually a question in the Q&A wondering about these edge cases. And is there a way that people can educate themselves um, about the edge cases? Sean mentions emission point trends, fiber panel anomalies.
Oh man.
He wants to send the researchers the best data possible. So,
And
That's
we
awesome.
but I
appreciate
don't think that's really represented here in these images.
right.
Yeah.
Yeah.
So,
All right.
Sean, you'll just have to, I don't
Done
know
and
what.
talk. You could done and talk it and say,
That's
I
true.
want to know more.
That's true. Good idea. Yeah. Send them a note.
All right, I'll go ahead and push it forward. I said keep per the example or per the suggestion of Lindsay, Dr. House. Ooh, how do we feel about this one, folks?
Wow.
All right, I see Nathan says throw. I trust him because he's an active volunteer.
Me too.
And a bunch of you probably are too. Toss that bugger. Love it,
I mean,
Michael.
a question for you, Lindsay. So, because I keep coming, maybe because it's white and my eye really goes to the spectral lines. Do we
Yeah.
want a very, very defined peak? Like this is a mound.
Yeah, exactly.
Okay.
And so that mound would be good if we were also seeing that oval in the other colored boxes, because that would mean it's a
Ah,
black hole. So it would
okay.
be okay if it was a mound in that case, but in this case, since we're not getting anything else really from the other images, I would say throwback.
Okay.
All right, I'm gonna hit throwback, and someone just asked about how the talk aspect works. So I'm gonna go ahead and hit done and talk to kind of close us out. But before I do that, is the red box supposed to be centered on the objective view red box? So all of these are different clustering versions of looking at that center image, or how would you better describe that?
Yeah, I think maybe they're talking about the red box here on the right, like the
Oh,
big zoomed in and zoomed out version. And so it's gonna be centered on whatever we're supposed to be looking at. So all of the things on the outside in the other images are not a part of what we're considering. Those might be in other things that come up, but what you're looking for is whatever is right in the center of those boxes. So if you don't see anything there, then that probably means throwback.
Okay. All right, I'll go ahead and hit done and talk. It's going to take me to another tab in which I will be able to look through and see, start a new discussion. So essentially, I could add a tag and say, I don't know, this would be, oh, here's some existing tags. Black bad data, nearby galaxy, no strong yellow flex dot. Yeah, lots of, ooh, good training example throwback. Would this be a good one for that? Sorry, interrupting your mini break.
Um, yeah. Uh,
Just for fun and adding things. So I could say, we did this one during Do NASA Science Live, which is not helpful information, I'm sorry.
Beautiful.
But it at least demonstrates how to use this. And we would just put this on notes or, oh, this is new actually. I didn't realize they had the ability to switch between different sections or discussion boards. So I'll go ahead and just leave it there, but you can choose if you want to, like if it's great for education for whatever reason, you could specify that talk board, for example. Add your comment. Oh, I think my Wi-Fi is having issues. I hope I'm not blurry. But I'll go ahead and assume that yours will probably work better than mine, whoever's trying to do done and talk on your computer. All right, this has been excellent. I'm gonna kind of pause us here for a moment. I know there were a lot of questions in the chat, and I'm so sorry if we didn't get to all of them. Sarah, were there any that stood out as something we need to answer before we drop off? Otherwise, I'll send all the questions to Lindsay to see if we can kind of group some answers too, to make sure we can at least answer you in the way that we can between now and when you next participate in this project.
Well, I'm thinking they are quite specific.
Oh,
Oh, you
well,
know
there.
what? I'm sorry, Lindsay, I did just
Oh,
find one that was like a juicy one that I thought was a nice kind of closeout.
Ooh.
okay. Okay, sure.
How do citizen science projects like Dark Energy Explorers help shape real discoveries about dark energy and cosmology? So, what is the point of all this?
Yeah. Yeah. What is the point? Well, I mean, this is real data from our telescope. Like, this is real data that we're going to use. Um, for making this map of the universe, for understanding how dark energy has evolved over our universe's history and over cosmic time. So you are a part of the project now, and that is exactly how you're helping to understand dark energy. The one thing that I wanted to make sure that people left here today, if there's one takeaway from today, it's that the difference between dark energy and dark matter. So dark energy, because they're almost like competing forces. The names are easy to confuse because they both have that similar first name of dark, but that's because they both haven't been visibly detected, like we talked about earlier. But dark matter pulls things together while dark energy is repulsing or pushing things apart. So that's my easy way to remember dark energy versus dark matter. And hopefully, we'll know the difference and won't get those two confused, even though it's tricky.
I love it. Oh, that was super helpful for me. I hope it was helpful for others. And a good lesson to take away. I did see, so Kara, thank you for giving another example. Yeah, there are so many examples of how these types of projects just lead to intense discoveries, just such incredible things.
Yeah.
Like the exoplanet Percival that was found a year and a half ago. Like that's or a planet in a habitable zone. That we're now looking into because someone from Planet Hunter's tests found it. So there's all kinds of things that can happen outside of space research too. Like how many species of bacteria are in your belly button. I'm sorry. Don't look it up, but we do know. So not a good answer. So to go ahead and like kind of close this out a bit and give you all a way to walk away from this with more information, I did want to let you all know that there is a flyer that you can take and download and print or just have available to you if you just need a quick way to get started again or share this with others. We welcome you to do that because we want to make sure that this data is something we can get through, even though it's billions upon billions of images. We can do it together. And so it is available to you either through this QR code or Roland just dropped it into the chat. If you're viewing through a watch party or you are registered for this event, that means you will get a recording and details later based on what we talked about today, and also any other questions that we are able to answer before that is sent out. Rob, so you're saying no end in sight for data. Yes, there's so much data, and it's not just Dark Energy Explorers. There's other projects. For example, if you want to do this again, we will have more for you in April, which is Citizen Science Month. I promised I'd talk about it later, and then we just didn't have a ton of time. But in April, it is Citizen Science Month. So if you do this project, Dark Energy Explorers, or you join us again and learn about other projects like cloud spotting on Mars, where you become the first ever meteorologist on Mars. Don't quote me on that because that's technically not what it is, but it is a fun way to think about it. You can join us again in April. I'll make sure to send the sign up links and such in the registration follow-up email as well. But if you are signed up for SciStarter and for the Zooniverse project or a Zooniverse account, everything you do on Zooniverse is going to count for Citizen Science Month, which is a really big deal for all of you who are in America, especially because it is this year is a big volunteer effort tied to the 250th anniversary of the independence, the Declaration of Independence being signed. And so there's a giant volunteer effort being calculated this year, and we are a part of it. We're an official partner, we being SciStarter in this case. So if you are able to join us in April, we would love to have you because then all of this work counts towards something even bigger than just one project that's just casually mapping the entire universe. But it is kind of big than all this.
As one does.
As one does, yes. So we hope to see you then. There's two other events that are NASA funded during April as well, and then another two that you can be a part of that are unrelated to NASA science, but great for other science purposes. If you are here today with us listening in either to the recording later or you're here with us now, we would like to know how you feel about all these events and what would make it better. Roland just dropped the link in the chat for you all to just drop straight over to the survey. It is literally 2 questions, open answer of just whatever you want to say about this. And so hopefully we can get some data on how you would like these to improve. If any of your responses, by the way, are it's too short, I totally agree. We're going to be spending 2 hours with everyone in April. So I appreciate Lindsay being willing to do the rapid fire version of this as we move into a longer time period during April. And with that, I'll go ahead and drop my screen share and thank you all. And thank you so much, Lindsay, for being here and sharing all your knowledge with us. I learned so much, way more than I thought I would, because the people in the chat are such excellent question askers too. Like these were crazy, awesome questions. Excellent job, everyone.
Yeah. No, this was great. Thank you, everyone, for coming. This was super, super great. And I hope that you continue on the project. And yeah, we'll hopefully send you a lot more resources if you're interested. But thank you guys so much for coming. This was really great.